In this video, we look at the count data model, more specifically Poisson regression, which is one of the member of Generalized Linear Models family or GLMs. Let us start with a very brief background of count data model. Many data in social sciences as well as natural sciences takes the form of count. For example, number of doctor species, which is used as an indicator of healthcare demand. I work in the field of household food insecurity measurement, so we often use count data in our econometric modeling. For example, number of food related coping strategies or CSI. This is one of the measures of food insecurity, one of the indicators of food insecurity, and it's a count data, count variable. We often use Household Dietary Diversity Score or HDDS. It is a good indicator to measure the dietary diversity of the household, and this is constructed by totaling the number of food items consumed by the households before the survey, 1 week prior to the survey. So these are some of the examples of count data. Several econometric methods are available for analyzing such data. So they can provide useful insights and efficient estimates that cannot be obtained from standard or linear regression model. Some examples of count data models are negative binomial, zero inflated count models, zero truncated count models, hardened models, random effects count models. These are some of the models that deal explicitly with count data or count outcome variables. Among different models, Poisson regression is a popular tool for modeling the count data, and it's widely or extensively used in social sciences and natural sciences data modeling. Why should we use count regression model? As I have just mentioned that count data is common in a vast array of applications from social sciences to the physical sciences. In fact, we cannot model the count variable like linear regression or binary regression without special treatment to the count variable. If we use linear regression in count variable, then linear regression model can result in inefficient, inconsistent, and biased estimates. That's why we use the count data model or Poisson regression model in count variable. This is very important to know the Poisson distribution of the count data model or Poisson regression model. The Poisson probability distribution takes this following form, where here the lambda is the mean of the expected value of the Poisson distribution. Lambda is also the variance of Poisson distribution, and Poisson is one parameter of lambda. So let us do a practical estimation process, or let us see a practical example. So we are using EVUs to estimate a count data model, and we are using the same data set from the previous video. So we are creating a work file with unstructured data. Our we have 754 houses information here. So we are importing the data into the work file. These are the variables in our data file. So we want to estimate the dietary diversity scores of the households, how these are influenced by households' other socioeconomic factors. So as our dependent variable is households dietary diversity score is DDS, here is the variable. So these are the count of the food items consumed. So this is one of the examples of count variable. So our dependent variable is DDS. Then we are taking the constant. Then we have number of independent variables. So next step is we are setting the estimation into generalized linear models, and we are choosing the family as Poisson regression and taking the link and the link function is log. So we are estimating the model now. Here is the result. You can see the probability value here, the coefficient of independent variable, standard error is here, and the Z statistics is here. One interesting thing is we can see that as a goodness of fit, we cannot see the R square or adjusted R square value, but we can see the Akiku information criteria and the AIC in case of count data model. And the goodness of fit statistics are different in count data model than those of our linear regressions. So that's all about count data model, and thank you.